Dr. Joyce, an affiliate associate professor with over 13 years of teaching experience. Dr. Seeley's research in evolutionary computing and machine learning has been published in esteemed journals. Her session on the role of evolutionary optimization techniques in biomedical data interpretations will introduce us to powerful algorithms that can optimize and improve the accuracy of our AI models, a vital aspect of next generation AI. Now I request Dean Academic Sivabrata Mohanty sir and Coordinator Soruma Arya ma'am to give the flower bouquet to extend dignity. Now I request Dr. Joyce ma'am to start their session. Jai Jagannath. Dr. Jayashree from GIET University, Bhubaneswar, and today I am going to give a talk on the role of evolutionary optimization techniques in biomedical data interpretation. So, before starting, I am deeply thankful to the organizer of this FDP, Next Gen AI Techniques for Biomedical Data Interpretation, for inviting me and giving this opportunity. It really means a lot for me to stand here and speak on a topic that is very close to my heart, actually. So normally, afternoon sessions are quite boring, okay, from the student point of view, right? So let us start with a very good story. Very small, but very good story. And you listen to the story and try to feel this story, okay? Because everything we should do heartily, that is important. Just imagine a situation in a flood-hit village, Monya Prapadita Anchal. In a flood-hit village, a doctor sat in his broken small cabin and surrounded by a huge chaos. It is a flood-hit village. The roads were broken, electricity was gone, and probably the last boat carrying the medicine would not return for weeks. So just try to feel this. It's a flood affected area, and the last boat carrying the medicine would not return for weeks. Okay? So around 10 patients were there outside the chamber of the doctor. All are waiting, all are praying. There was a very young boy, very small boy, burning with fever, and his little hand clings to his mother's side. There was a young lady gasping for breathing. Okay, and she holds her very small kid to his chest, to her chest. Okay, very close to her chest. But she was gasping for breath. Okay. Another older farmer was there. His wrinkled face was very calm and quiet, but his heartbeat, unfortunately, very weak. Okay, he was suffering. So, like this, many patients were there outside the chamber, and all are having all are having a hope on that doctor. So the doctor will save their life. Okay. Now again I am recalling that this is a flood affected village. Okay. The last boat carrying the medicine would not return for weeks. Now what the doctor will do? The doctor opened his medicine box. He saw some very few capsules, injections and tablets were there. Now his hand trembled. What he will do? He whispered to himself, to whom do I say first? The doctor thought, to whom do I say first? The little boy who has a very bright future ahead, or the young lady who has a very small kid depending on her, or the older farmer who is responsible for feeding the entire villagers. Okay. Now tears welled in his eyes. The doctor wanted to save everyone's life, but he knew that he couldn't because very limited medicines were there. Okay. So now again he thought that what he will do, to whom do I serve now? Okay. First, to whom he will first give the service. Just try to feel this situation. This was not a medical crisis. This is actually an optimization problem of life and death. Because with the limited resources, with the multiple conflicting priorities, and with time running out. Okay. So the doctor had to make a decision which is the best for that moment. So like that doctor, in our real life, always we face these things. Because human wants are unlimited. Yes or no? Always we try to achieve more and more. Multiple things needs to be satisfied for us. Okay? So that is known as optimization. We want this, we want this. We need to minimize this, we need to maximize this. Okay? So this is the essence of optimization in our real life. Now I hope all of you have understood what exactly the optimization is. Okay. Now let's start. So these are the points which I will be covering now. And already I explained what is optimization. Optimization is a problem where the problem is having multiple solutions. Not a single solution, having multiple solutions, but we have to choose the best one. Okay. Suppose I want to travel from Bhubaneswar to Bhubaneswar. So I have many alternatives. I can go by car, I can go by train, I can go by the local train or express trains or AC train, Rajdhani Express or anything. Many alternatives are there. Buses are also there. But which one I will choose? All are the solutions. Because I want to move from anyhow, I want to reach to Bhubaneswar. So all are the solutions. But I have to choose the best one. Okay? So now how to choose the best? So choose the based on, again it depends on some objective functions. Okay, what is my objective? If my objective is to save the money, that means I want to reach Bhubaneswar with less cost. So at that time I will go by local train. Okay. If someone is waiting for me and I need to reach Bhubaneswar very fast, so then I am not bothered about the money. Here my objective is to minimize the time. Okay. So I will go by personal car. So choosing the best solution depends on the objective, whether the minimization or the maximization. Okay. So this is the real world optimization problem. Each and every time we face this problem. Okay. So nowadays everywhere AI, ML, you know. And now deep learning, next generation AI, generative AI and ChatGPT very friendly to us. Okay. So everywhere we are talking about this. But everywhere the background, okay, in the background optimization is working. So the role of optimization in artificial intelligence, this is not possible to explain in one talk of around 1.5 hours. But I will try to compact this session with a very few application areas. So as we all have computer science background, MCA, BCA, computer science, so always we need some mathematical foundation. Okay, without mathematics we'll be unable to write a program. Yes or no? So how to formulate the optimization problem mathematically? Always the optimization problem consists of one fx. Fx is the objective function. I told you just now whether to minimize the time, whether to minimize the cost. Okay, that is your optimization function. It can be either minimization problem or maximization problem. Again, there are some constraints. In real life, every day we are facing these constraints. Okay. For example, suppose you all are master degree students or graduate students. So suppose TCS, one company will come here for equipment. Okay. Now they are having one constraint. They are coming to your college means you all are feasible solution. But their constraint is, suppose CGPA more than 8. If your CGPA is greater than equal to 8, then only you are eligible to sit in the interview. So that is the constraint. Okay. So every time the optimization problem includes one objective function and some set of constants. Okay. Mathematically these are equality constraints or inequality constraints. So now the two most important concepts of optimization is search space and feasible space. Just now I told you, suppose TCS will come to your college for equipment. So now total entire college is your search space. From this entire college, suppose 1000, 2000 students are there, they will select any 20 or 30 students. So the search space is your entire college. But what is feasible space? The space satisfying the constraint. Now they are having the constraint, the students having the CGPA greater than equal to 8 are eligible for the equipment. So now from the entire search space, they will screen, they will do the filtering of the students who are having the CGPA greater than equal to 8. So that is your feasible space. So feasible space is always a subset of the search space. Right? So the space, the entire space of searching is known as search space, and the space satisfying the constraint is known as your feasible space. Now again mathematics. Without mathematics nothing is there. So see this diagram. X coordinate, suppose the range is 0 to 10, and y coordinate, suppose the range is 0 to 1. So this x coordinate 0 to 10 and y coordinate, this rectangular region is your search space. But if I am drawing this line and I am saying that the solutions lying inside this area are feasible. That is, this is the entire search space and this shaded area is your feasible space. Okay, satisfying the constraint. Again I will give you another very good example. Suppose you want to minimize a function fxy is equal to x square plus y square. must be positive, y must be positive, and x plus y must be greater than equal to 1. Okay. Now see. So x greater than equal to 0. This is x infinite up to y greater than equal to 0. Okay. So now this is your search space. Completely search space. But what is feasible space? Feasible space is satisfying the condition x plus y greater than equal to 1. So this line is your x plus y is equal to 1. This red line. That means from this entire search space, which is your feasible space, the green shaded area. Because this line is your x plus y is equal to 1 and our constant is x plus y must be greater than equal to 1. So that is why out of this search space, the green area is now becomes your feasible space. So no need to search this white area. Even if this is under search space, but this is not feasible space, so you don't need to search here. You have to search the solution here. So now what is the solution? Because your objective function is fxy is equal to minimize the value of x square plus y square. So in this green region, many x value can be possible, many y value can be possible. So you have to find out where the x square plus y square is the minimum. So this is your optimal solution. X value 0.5 and y value 0.5. If you find out x square plus y square, that will be the minimum. Okay. So this is the difference between the search space and feasible space. Next, another important concept is global optima versus local optima. If I want to find out the best student from this conference hall, okay, so that is the local optima. If I want to find out the best student from MCA, that is the local optima. But if I want to find out the best student from the entire college, then that is global optima. Okay. For a particular region, which is the best solution, that is known as your local solution or local optima solution. But for the entire search space, the best solution is known as your global optima. See this. Suppose this is one minimization problem. What do you mean by minimization problem? You need the minimum value. Okay. If I consider only this area, which is the minimum value, this one. So this is your local optima. If I consider this area, this is again minimum, this is local optima. But entire search space, this is the entire search space and this is the global optima. Understood? This solution, no doubt, this is the local optima for this area. This is the local optima for this area. This is the local optima for this area. But for the entire search space, this is the minimum value. So that is your global based solution. Okay, local based and global based solution. Within a particular region, within a particular level, if a solution is good, that is known as local optima. From the entire search space, the best solution is known as your global optima. Next, just beginning of the session, I started with a story where the doctor had to take a decision with many constraints, like time is running out, limited medicines are available, different patients were having different health conditions. So satisfying all the objectives in real life and taking a best decision is very tough. Okay, but in real life, each and every time we face this problem. Always we need to satisfy multiple objectives. Suppose you are coming to college. What is your objective? You want to save your time. Within short time, you want to reach here. You want to save your money. Okay, suppose Ola, Uber or something you want. That means always you want to satisfy the multiple objectives. So that is known as your multi-objective optimization. That means optimization problem involving multiple objectives. That is known as your multi-objective problem. Okay. But why this is a challenging topic? Nowadays, multi-objective optimization is a very big challenge to solve this kind of problem, because always the objectives associated with the multi-objective problem is conflicting in nature. So conflicting means what? Contradiction. Okay. showroom and find the different cars and their cost, and I select the one which is having the lowest cost. But it is single objective because my objective is to purchase a car having the lowest price. That is my single objective. But multi-objective means, suppose my objective is to purchase a car which is having the less price and highest comfort. Price is less, comfort is high. So is it possible in real life? This is quite contradicting. Yes or no? Am I right? So if the objectives associated with the multi-objective problem is conflicting in nature, at that time it is a big challenge. Because you will not find a single solution or a single car having the lowest price and highest comfort. It is very tough. Yes or no? So multi-objective optimization means the problem associated with more than one objective. So now why to use multi-objective? Why to use the MOO, multi-objective optimization? Because the real world complexity. Our world is very complex. Every time taking decision is very tough for us. Okay. So real world always will face the complexity. Informed decision making. Always we need to make a good decision by taking many things into consideration. Okay. And finding better solution. Yes. Because I told you in case of single objective problem, it is possible to get a single solution. But in case of multi-objective problem, it is very difficult to get a single solution satisfying all the objectives. Okay. Now examples of, already so many examples I have given. For example, if you want to design some machines or engineering design, you want to maximize their performance. Suppose you want to design one machine. So you want to increase its performance, maximize its performance, but minimize its weight, minimize its cost, minimize its fuel consumption. Okay, so these are multiple objectives. Similarly, resource allocation. Suppose suppose here you are having 100 chairs. Okay, how to arrange these 100 chairs so that maximum students can be present here. So resource allocation, how to optimally allocate the resources. So in many places we use the multi-objective optimization problem. Now, whenever we want to solve this kind of problem, I already explained what is the search space and what is the feasible space. Now, what is decision space and what is your objective space? Suppose the function you want to minimize fx is equal to x square plus y square. So here fx is still now we have not got a single solution. Similarly f3, suppose maximize f3. For green one, what is the maximum point? This one. For sky one, what is the maximum point? This one. That means all four solutions are different. There does not exist a single solution satisfying all the four objectives. Am I right or not? Okay. But in this case, it involves with a single objective. So if it is minimized, we will get this solution. If it is maximized, we will get this solution. But here, as we are working with multiple objectives, so no single solution exists which satisfy all the four objectives. Okay, so this is a big challenge in case of multi-objective optimization problem. So what is the ideal solution? If suppose I have two objectives, f1 is to be minimized and f2 is to be minimized. That means suppose two objectives are the minimization. Then what is the solution means really? Actually, this is the solution. Because in this point you say f1 is the minimum value and f2 is the minimum value. Yes or no? But in real world this is not possible. In the real world it is not possible to get the ideal solution. Always you will find this type of problem. Like the example car. If cost is less, comfort is less. Cost increase, comfort increase. So the car is just like this, not a ideal solution. Okay. In real life it is not possible to get the ideal solution. Always we will get the conflicting solution. Some solution is based in one objective, some solution is based in other objectives. So that is why there is a concept concept in multi-objective optimization, that trade-off solution or Pareto optimal solution. This is very important part of multi-objective optimization technique. The term trade-off or Pareto optimal solution. Pareto optimal solution means what? The solutions all are good. That is the solution, all are good. For example, in the first row, suppose 5 students are there. Okay, he is good in study. He is not very good in study, but he is good in extracurricular activity. Suppose he is not good in study, somehow good in extracurricular activity, but he is having a very good speaking power. That is nowadays which is most important. Okay, so all the 5 students are good. He is good in some objective, compromising with other objective. He is good in other objective, but not in other. Okay, so that solutions are known as Pareto optimal solution. That means all are good. Because in multi-objective optimization, it is not possible to get a single solution. Always will get the multiple solutions. Now, so this type of multi-objective optimization problem, to solve this kind of problem, we use the evolutionary algorithm. Have you heard the term heuristic, meta-heuristic? Okay, you all are from MCA. Right? Do you have the topic genetic algorithm? No. Okay. So we use the evolutionary algorithm to solve the problems, solve the optimization problem, where the search space is very huge. Search space is very huge. I am giving you one example. Suppose again the same example. Suppose I want to find out the best student from this conference hall. You are having suppose 40 students. So I list 40 roll numbers. Each roll number, first roll number, suppose CGPA is 8. Second roll number, CGPA 8.2. Like this I will list. And it is very out of 40. I will simply find out which student has secured the highest CGPA. So he is the best student. So out of 40, finding the best solution, it is very good. But if I want to find out the best solution, the best student in his ward, so is it possible to write the roll number of each student in the ward and write the CGPA against him or her, then calculate the best student? Is it possible? So evolutionary algorithm works there. So whenever the search space is very limited, suppose this is, then you can go for the traditional method, manual method. But if the search space is very huge, at that time the traditional method will not work. Very time consuming. So we'll use the evolutionary algorithm. So I can say the traditional algorithms are point by point approach. That is, for each student I am writing the CGPA and I am finding the best student. That is point by point approach. But evolutionary algorithms are population-based approach. They don't work in point by point. If I want to find out the best student of this world, so first I will start with a very small region. Suppose for each district, many colleges are there. From each college, I will take one best student. Okay. For Khordha district, suppose 50 colleges are there. From 50 colleges, I will get 50 best students. For suppose Cuttack district, for Bhubaneswar district, so many districts are there. From each college, I will get one best student. Understood? Now from each district, I will get one best student. Okay, suppose then for each state, I will get one best student. For each country, I will get one best student. Then I will calculate the best student of this world. That means the evolutionary algorithm works with population of solution, not point by point. Okay, always, because the search space is used. If the search space is only 20-40 members, it is very easy to find out. But if the search space is very huge, at that time counting each and individual student's CGPA and marking the best student is not practically possible. So it always works with the population. Okay. And evolutionary algorithms are based on the natural evolution, our genetic evolution. Darwin's principle, those who know biology, from the biology background, you know what is Darwin's principle. So our natural evolution, based on this, evolutionary algorithms are built. So this is the working principle of the evolutionary algorithm. As I told you, first initialize the population. Suppose I have fixed best student. The next 100 student, best student. Like so, initialize the population. Next part is fitness calculation. Fitness calculation means what? Just now I told for each student you have to calculate the CGPA because I want to maximize the CGPA. That is your fitness calculation. Then termination criteria. Remember, evolutionary algorithms are iterative approach. Just now I told you that it will start from the colleges, then it will move to the district, from district to state, state to country, then country to world. So it is an iterative approach. Okay, so you need to stop somewhere, otherwise it will go for infinite. So this termination criteria you have to check whether you have reached the termination criteria or not. If yes, you can output the result. If no, you can go for these operators. These three operators are very important for your evolutionary approach. So the most popular evolutionary algorithm, the base algorithm, is your genetic algorithm. Okay. In genetic algorithm, three operators are used. One is selection, another is crossover, another is mutation. So you have started with the initial population. Now if you apply these operators to the initial population, you will get some different set of population. Okay. So again you find out the fitness and again find out the base from that population. So this process will be continued until and unless you are getting the global optimum. Okay. So this is the procedure of evolutionary genetic algorithm. Now, for better understanding, I am giving a very good example. See, suppose this question is maximize fx is equal to x square. Listen carefully. Maximize fx equal to x square. And x lies from 0 to 31. X lies from 0 to 31. What is the answer? I want to maximize x square. And x lies from 0 to 31. So what is the answer? For which value of x you will get the maximum x square? 1. 31. Because 0 to 31, obviously 31 square is the square. So this is very simple range from 0 to 31, so you are able to answer it. But suppose it is 0 to 31 million or billion like this, then is it possible to find out? So this is a very simple example. How genetic algorithm works here. Your answer is 31, I know. But as this is a small problem, you can tell it easily. But whenever the problems are very huge, so at that time, how genetic algorithm works. So I told you that it is a population-based approach. So it will start with the initial population. Here I have fixed the population size is 4. That means at a time 4 solutions will work. So see here, suppose I have initialized the population 1, 2, 3, 4. What is the binary value of this? 12. Next one is 25. Next is 5 and next one is 19. So our range is 0 to 31. So all are in the range of 0 to 31. Now you calculate the fitness. What is your objective? Maximize x square. So calculate the x square value. 12 square 124, 625, 25, 40. You have calculated. Okay. Now from this solution, because now you have chosen only 4 solutions, you have to, this is an iterative approach. How the selection, I told you that there are 3 operators, selection, crossover and mutation. How these 3 operators work in genetic algorithm. First, after calculating the fitness of 4 solutions, find out the probability. You see, from these 4 solutions, which one is having the highest fitness? 25. Okay, so 25 is having the highest fitness by 1155. This, like this you calculate the probability. So now you see which solution is having the highest probability? Second one, because its fitness value is more. That means selecting this solution to the next generation, the probability is high. Okay. Next is equal to the total population size. Here population size is 4. 4 into probability. So 4 into 0.1247 this one. 4 into this one. 4 into this. Okay. So now after finding out expected count, find the actual count. 0.4. So you take the floor value. So it is 1. 2.162, 0.080, 1.25, interpret this actual count. 1, 2, 0, 1. See, the solution having the highest fitness, its actual count is 2. Okay, and the solution having the lowest fitness, its actual count is 0. That means for the next operator, this is the selection operator. For the next operator, how to choose the population? First solution count is 1. First solution, what is the first solution? 0, 1, 1, 0, 0. That will go 1. Next solution count 2. That means 1, 1, 0, 0, 1 will be repeated twice. And the third solution 0. And fourth solution number of times is 1. So see the next. After this, first solution 0, 1, 1, 0, only single time. Second solution 1, 1, 0, 0, 1, it is twice. Third solution 0 and fourth solution 1. So this is the selection operator. How to select the best solution for the next operator? The solution who is having the highest fitness is having the highest probability to go to the next generation. Okay. Now the next operator, that is crossover. For crossover operator, you have to fix the crossover point. This is up to you. Okay. Now suppose for the first crossover, I have chosen the crossover point is 4. That means after 4 bits, you swap the bits. For the first two chromosomes, see here, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1. After 4 bits, 1 will come to here, 0 will come to here. So see the solution. What is the first solution of 0, 1, 1, 0? Now 1 comes to here. And for this 1, 1, 0, 0 and this 0 comes to here. Now for the next two, I have chosen the crossover point is 2. So that means after 2 bits, the values will be exchanged. So the third solution is 1, 1, 0, 1, 1. Second solution is 1, 0, 0, 0. So after crossover, you got this 4 solutions. Now find out their x value, binary equivalent, decimal equivalent. 13, 24, 27, 17. Now find out the x square value. So now which solution is best? 27. Okay. But earlier, in the first, which one was best? 25. After applying crossover, you are very close to the solution now because you know the solution is 31. Now you reach 27. Okay. Now next operator is your mutation operator. Mutation operator means you have to, mutation means what? You have to mutate, that means flip the bit. Okay, you have to flip the bit. But remember, always crossover probability is high, mutation probability is very low. Okay, so that is why I have generated the mutation chromosome. That means how many total number of bits were there? If one solution 5 bits, so 4 solution 20 bits. Okay, out of this 20 bits, I want to flip only this, this and this. So out of 20 bits, you just flip only 3 bits. Okay, which 3 bits? First, this is 1. That means in this place, 0 was there, now it is 1. Flip means if it is 1, make it 0, if it is 0, make it 1. So you check this chromosome. 1, all are 0. That means first bit will be changed. So here first bit was 0, so now it becomes 1. Similarly from the second, none of the bits are 1. So that means no change. Third one, no change. Fourth one, only third bit and fifth bit are 1. So third bit it was 0, now it is 1. Fifth bit, earlier it was 1 and now it is 0. Okay, so after mutation, you got this chromosome. Now you calculate the binary equivalent. 29, 24, 27, 20. Calculate x square value. So which one is the maximum? 29. So you started with the base solution 25. After crossover you reach to 27. After mutation you reach to 29. This completes your one generation or one iteration. But evolutionary algorithms are iterative approach. You have to continue the loop. Okay. After the first generation, you got the base solution is 29. If you continue this process, definitely you will reach to 31. Okay. So in this way, evolutionary algorithm works. And remember, the point are evolutionary algorithms are population-based approach. Always they work with the population. And second thing is that it is an iterative approach. In In single generation we can't start. To get the optimal solution we have to iterate. Now this the question I explained, that is fx equal to x square, only single objective. But our aim is to solve the multi-objective problem. In case of multi-objective, multiple conflicting objectives are there. Now, how to decide that which solution is the best? Okay. So to decide this, we use the concept first how to solve this multi-objective problem. There are basically two approaches to solve this multi-objective optimization problem. First one is the priority approach, second one is the post priority. What is priority approach? Given multi-objective problem, that means multiple objectives are there. Minimize F1, maximize F2, minimize Fn. So multiple objectives are there. You use some high-level information. What is the meaning of high-level information? Suppose you are able to again purchase a car having less cost, highest comfort. Now you give some weights to each objective. Suppose for you, cost is the important. So you give highest weight to the cost. Suppose 0.8 and 0.2 for the comfort. Suppose someone else, comfort is the most important. So he or she will give suppose 0.7 to the comfort and 0.3 to the cost. So similarly you distribute the weights. Then you calculate this value. Weight into F1. That means you suppose you have two objectives, W1 F1 plus W2 F2. So now the multi-objective problem becomes a single objective problem. Because earlier it was F1, F2, Fn, many objectives. Now it becomes only single objective, W1 into F1, W2 into F2. So this is a single linear function. Okay. So you converted the multi-objective problem to the single objective problem. Now you can solve easily. So you will get the single optimal solution. But what is the drawback here? Deciding the weight. Deciding the weight is very important. It takes some expert knowledge. How to give weights to multiple objectives, so that needs your expert knowledge. So deciding the weights is very important, and this will create the problem. So for that, better approach is to go for the multi-objective approach. Here you don't have to convert the multi-objective problem into the single objective problem. You directly work with the multi-objective problem. See, the objectives are given. You use the multi-objective optimization. No need to convert it into single objective. Then I told you that for single objective problem it is possible to get a single solution, but multi-objective problem it is not possible to get a single solution. Rather, you will get multiple Pareto optimal solution. I told you again what is Pareto optimal solution. That means the solution all are good. Some one solution is good in one objective, another solution is good in another objective. So all the solutions are known as Pareto optimal solution. So you will get a set of Pareto optimal solution. Now suppose at the end of the algorithm you got 5 best solutions. Now you can choose any one depending on your choice. If I have 5 options, then I can choose any one from them. See the situation. Suppose you want to purchase a car, you have only one option. That means you are bound, you are forced to purchase that one. But if in a showroom multiple cars are available, you can see here and there, and according to your priority, you can choose any one. So which one is easier? Second approach. Okay. In the first approach, you will get only a single solution. So you have to take this solution. But in the second case, you will get the multiple Pareto optimal solution. All are good. So now according to your priority, you can take any decision. So the second approach is basically more fruitful. So nowadays most of the researchers are directly working on the multi-objective approach. So now how to decide the Pareto optimal solution? Suppose you are having 100 solutions. You are having, now suppose 40 students are there. So how I will find out the Pareto optimal solution? Again, to find out the Pareto optimal solution, you have to remember that Pareto optimal solutions, that means the solution which all are good. One is good in one objective, another is good in. So how to find out the Pareto optimal solution? For that we use a concept that is known as domination. The English meaning of dominance, you know. Okay, someone
there are two conditions. Suppose two solutions x1 and x2. x1 dominates x2 whenever it is first condition. If both the conditions are satisfied, then only you can say that x1 dominates x2. Now when x1 dominates x2, first condition is x1 is not worse than x2 with respect to all objectives. Not worse than, maybe equal, but not worse than. That is the first condition. Second condition is x1 should be strictly greater than x2, strictly better than x2, at least with respect to one object. Just now I gave you the example. Suppose all are having the CGPA same, but suppose he is good in extracurricular activities, he is good in speaking or he is good in reasoning, aptitude. Okay. So that means what? First condition is x1 is not worse than x2 for all the objectives. Maybe equal but not worse. Second condition is x1 should be strictly greater than x2 at least with respect to one object. Then only I can say x1 dominates x2. Okay. Now by this principle, what is Pareto front or what is Pareto optimal solution? The solutions which are not dominated by anyone. That is the non-dominated. The non-dominated solutions are the Pareto solutions. Understood? 3 points are very important. First one I told you what is Pareto optimal solution. That means the solution which all are there. First, how to decide the Pareto optimal solution? By the principle of domination. So what is domination? x1 dominates x2 whenever x1 is not worse than x2 with respect to all objectives, and x1 should be strictly better than x2 at least with respect to one objective. Okay. When both the conditions satisfy, I can say x1 dominates x2. This is the general definition. Now what is the Pareto solution again? Pareto solutions are the non-dominated solutions. No one can dominate them. They are the best. Okay. So Pareto solution means non-dominated solutions, which are not dominated by anyone else. Clear? Now see, suppose there are two objectives. First f1, another is f2. f1 is to be minimized and f2 is to be minimized. Both the objectives are minimization problems. Clear? Now which one is the dominated solution, which one is the non-dominated solution? Because always your aim is to find out the non-dominated solution. Okay. How many solutions are there? 3. How to find out that which solutions are non-dominated solutions? Suppose, first check the dominance. I want to check whether x1 dominates x2 or not. x1 dominates x2. See this diagram. x1 dominates x2. Whether this is true or false. What is our objective? Objective is f1 to be minimized and f2 to be minimized. See the x1 and x2. First condition. x1 not worse than x2 with respect to all objectives. x1 not worse than x2 with respect to all objectives. So for the first objective, x1 is better because it is having minimum f1. For the second objective, x1 value same as x2 but not worse than. Yes or no? See. This is to be minimized, this is to be minimized. That means we need the minimum point for both. I want to check whether x1 dominates x2 or not. What is the first condition? x1 dominates x2 whenever it is not worse than x2 with respect to all objectives. For first objective, x1 is better than x2, yes or no? For the second objective, x1 is equal to x2, but not worse than. So the first condition satisfied. What is the second condition? x1 should be strictly better than x2, at least with respect to one rule. So here x1 is strictly better than x2 with respect to the first objective, because it is having the minimum level. So that means I can say x1 dominates x2. Understood? If both the conditions satisfy, then x1 dominates x2. So in this way you have to check who is dominating and this is another illustration. But the properties are, if I ask you, suppose x1 dominates x2, is it possible? Sorry, x1 dominates x1 itself. Is it possible? second condition is it should be better than at least with respect to one objective, but all are equal. Okay, so reflexive property is not true. X1 cannot dominate itself. So reflexive is not true. Second one is domination relation is not symmetric. That means if X1 is dominating X2, that does not necessarily mean that X2 is dominating X1. Okay. But transitive is true. X1 dominates X2, X2 dominates X3, that means X1 dominates X3. Okay, this is true. So after understanding the concept of dominance, always in multi-objective optimization, our aim is to find out the non-dominated solution. So how to find out the non-dominated solution? Check each solution. Suppose in this example, check every solution whether they are dominated by any of the solutions or not. If they are not dominated, then this is non-dominated. Okay. In this example, suppose I want to check whether one is dominated or non-dominated. So how you will check? First compare 1 with 2. Okay, suppose 2 is dominated. That means 1 is not dominated. Non-dominated means it is not dominated by any other solution. So after checking this, suppose for this problem I am getting 3 and 5. Both the solutions are non-dominated. Okay, so out of 5 solutions, 3 and 5 are non-dominated solutions. If we join the point 3 and 5, the curve joining the non-dominated solution is known as your Pareto front. Because non-dominated solution is nothing but the Pareto optimal solution. The curve joining the Pareto optimal solution or the curve joining the non-dominated solution is known as your Pareto front. Okay. Our aim is to find out the Pareto because we want multiple based solution. Out of this we can choose any one according to our plan. So I thought I will give you one task, but time will not permit. But this is again one example. Here F1 to be minimized and F2 to be maximized. F1 minimized, but F2 to be maximized. So can anyone tell me what is the solution? By seeing the plot only, no need to apply the concept of dominance. Directly by seeing this you can tell the answer. Which solution is the best answer? Is there any single solution where F1 is the minimum one and F2 is the maximum one? Which solution? Anyone hint I am giving? Yes, there exists one single solution which is satisfying both the objectives. But which solution? 2. Yes, very good. Because for 2, F1 is the minimum one out of all solutions, and for 2, F2 is the highest one out of all solutions. Okay, but in real life this is very rare. Single solution satisfying all the objectives, this is very rare. जैसे कि हम लोग बोलते हैं ना, extraordinary students. What is an extraordinary student? He or she is good in academic, he or she is good in extracurricular activities, speaking power, aptitude, reasoning, very good human being. From all point of view, sarva guna sampanna. Okay. So this is very rare in real life. But thank you. Give the answer. So now I explained each and every important concept of multi-objective optimization. Now for medical data set or biomedical data, we can use the optimization everywhere. So these are the application areas of utilizing the evolutionary optimization technique in the artificial intelligence. So out of this, I will now discuss only one point, that is your feature selection. Have you heard this term? So feature selection in biomedical data, it is a very important topic of research nowadays. Why? Because nowadays everything is digitized. Okay, in healthcare industry, everywhere, earlier when we go to the doctor, they normally write our features like what is our age, our blood pressure level, and from where we can address name, address, age, our blood pressure level, and every symptoms. Normally they write. Okay, but nowadays everything digitized. In the past sessions, sir told that the prescriptions are digitized. Okay, so now everything is getting digitized. figures like that. So for a single patient, we are writing multiple features. But just tell me one thing, to decide whether a patient is having diabetes or not. Name, is it important? Address, is it important? No. So these are not important features. But is that present? So now, it will digitize all this. It will make a data set. What do you mean by data set? Data set is a matrix format. So the features, that is name, age, address, blood pressure, sugar level, all these are the features. And number of patients are the samples. Okay. So now, to decide whether a patient is having diabetes or not, the important features are what? Age and your blood pressure, suppose your sugar level. These are the important features. Name and address, these are not important features. But how to identify the important features? That is known as your feature selection. Feature selection means whenever your dimension of the data set is huge, suppose the data set is having millions of features, but all the features are not relevant. So you have to discard the irrelevant features and you have to keep the relevant features only. So that task is known as your feature selection. And this is very, very important in case of biomedical data, because biomedical data is having the huge dimension. Dimension बहुत होता है. So you have to select the important features. That is known as your feature selection problem. So this is the medical diagnosis difficulty I told you just now. And what is feature selection? Suppose you are having a data set with complete set of features. Now you will apply any feature selection algorithm. You will get a reduced feature subset. Suppose out of 200 features, only 20 features are important. So why we will include 180 features more? Okay. So we will work with the 20 features. It will save our time. So feature selection, apply the feature selection algorithm and find out the feature subset. Then this process will be repeated and finally you will get the best subset of features. And again, mathematically you have to represent the feature selection problem. Given the data set D, just remember data set means set of features, set of samples. So assume the data set D is having n number of features, then your aim is to pick the optimal feature subset from D. Okay, and always the feature subset size is less than the original feature subset. Mathematically, feature selection problem is considered as a binary optimization problem. Time is there. So feature selection is your binary optimization problem. That means it is a string of zeros and ones. 0 means feature is absent, 1 means feature is present. Okay. So mathematically, how you represent? As I am talking about the multi-objective optimization. So this is my research I am telling. I have considered the feature selection problem as the multi-objective optimization problem, because my first objective is to minimize the number of features. Okay. And second objective is maximize the accuracy. So both are conflicting. Number of features is less, but classification accuracy you want higher. So both the objectives are quite conflicting. So that is why it is multi-objective problem. I told you multi-objective problem means it includes the contradictory objects, objective functions. Okay. So first objective is to minimize the number of features. Second objective is to maximize the classification accuracy. Now these are the major challenges or key factors of feature selection problem. Suppose there are three features. X1, X2, X3. I want to find out the best subset of features. So how many options are there with me? 0, 0, 0. That means all features are absent. Because I have three features. 0, 0, 1. What is the meaning of this? X1, X2 absent. Only present is X3. 0, 1, 0. X1, X3 absent. Only present is. So how many options I have? If 3 number of features are there, 2 to the power 3. That is 8. But we normally take minus 1. Why? Because 0, 0, 0 we don't take it. Okay. So 2 to the power n minus 1. If n is equal to the number of
features. So here number of features were 3. So 2 to the power 3 minus 1, 7. Just imagine if n is equal to 1 million. Because real life problem, the features are very huge. So 2 to the power, simply take 1000. 2 to the power 1000 minus 1. How many possible options are there? So from there you have to choose the best first. So this is the kind of NP problem. Have you heard this? I think you have studied the DAR, design and analysis of algorithm. DAR subject नहीं है, अभी है. So design and algorithm. So there, I told you that this is the NP problem. NP problem means non-polynomial time. It is not possible to find out the solution of feature selection problem in polynomial time because 2 to the power n minus 1 order of 2 to the power n. Okay. So that is why we will solve this problem by using the evolutionary approach. Now these are the challenges of medical diagnosis. I told you nowadays what are the problems. Now these are the matrices or the performance indicators. I told you in the multi-objective optimization problem, your output is your Pareto front. Your output is your Pareto front. That means the curve containing all the non-dominated solutions. Okay. Now suppose you have 5 algorithms. So you will get 5 Pareto fronts. So which algorithm is the best?
Take that.
Always we need the best. Na? So if you are having 5 algorithms and they will output 5 Pareto fronts, how to decide which one is the best? For that, these matrices are used: generational distance, IGD, inverted generational distance, Herschel values, spread and success counting. So in detail I have mentioned here, generational distance means what? Suppose these two are the generated Pareto fronts. Suppose algorithm A output is this, algorithm B output is this. But this is the true Pareto front. This is the true Pareto front. So which one is closer to the true Pareto front? The harder one. So that means the generational distance is less here as compared to this. Okay. So in this way we have to measure which Pareto front is the good one. Similarly, other matrices IGD and hypervalue and spread and success counting. So these are the matrices used. Now the last part, that after getting the Pareto front means curve joining the Pareto optimal solution. Again, Pareto optimal solution means it is not non-dominated solution. Non-dominated solution means they are not dominated by any other solution. That means they all are good. Now which one to choose? You need only one answer. But Pareto front contains multiple good solutions. Which one to choose? So for that we use the concept of crowding distance. Okay. Suppose this is the Pareto front. The solution which is present in the least crowded area. Least crowded area means if the solutions are very close to each other, that means they are very similar. If the solution is present far away, that means it is a unique solution. Okay. So the solution who is having the least or the highest crowding distance, that means this solution is the unique one. So out of these 6 solutions or 7 solutions, you calculate the crowding distance and based on this you decide which one to choose. Okay. Because if the sky is cloudy, there will be rain. We know this is a general thing. But if the sky is sunny but still raining, so that is the rare event and we see the rainbow. Yes or no? And rainbow is the rare event. So that means the rare event, the rare sample, the rare solution we want. Unique solution. So this is the algorithm to calculate the crowding distance. So based on all these concepts in my research, so first I have applied the genetic algorithm and second I have applied the multi-objective ant line optimization and third I have used the multi-objective Harisma optimization algorithm. So from the beginning I told you that evolutionary algorithms are based on the natural evolution. From nature they get the inspiration. Okay. So many algorithms I have used, but these 3 are the good ones. And out of this, the best result I got here for the Harisma optimization algorithm, because these are based on the Harisma is a bar.
result part. And in conclusion, I want to say that here I have applied the multi-objective evolutionary algorithm for feature selection in biomedical data. But in real life, everywhere you can use the optimization technique. Any research area, you can use the multi-objective optimization algorithm. Okay. And I have also, in my future research, I have also done many works in this area. And these are some of the references. Thank you. And
I have one doubt. So whatever the optimization technique you have used, can it is applied to mechanical field?
yes.
Okay.
You just tell me one problem in mechanical optimization.
Suppose we are basically in mechanical we are using gray analysis, gray regressional analysis, and stability analysis. Yes. You are optimizing, then our optimization technique is different compared to yours. Traditional. Suppose I have 9 experiments, I have 9 experiments in 9 or 4 they have used. I want to use in somewhere in your algorithm. Can it be suited or some conditions are there for applying volume? What should be the condition? What should be the set of data? Yes, that means after level. Yes, they are written. Okay. Data set diagnosis. Okay.
One thing, student, there are two things. One is heuristic, another is meta-heuristic. So these evolutionary algorithms are meta-heuristic. Heuristic means what? A guessing something. Suppose you want to prepare a cake in micro oven. You want to set the temperature. Okay. Suppose you guess that this temperature, X temperature is best. But X temperature is not good for your tandoori chicken. Okay. For cake, X temperature is good. But for other problem, this will not work. Okay. But meta-heuristic means these are the algorithms are general. You can apply in any area. No problem. Thank you. Any questions? Okay, thank you everyone for your patience. Students, thank you very much because I love my students a lot. And thanks to you because you are very silent and you are listening and we get the answers also. So thank you.
Silent. Thank you, ma'am, for this beautiful session. Now I request Bhubaneswar sir and Soul Fire ma'am to felicitate our guests.
Hey,